Okay, back on this PLL thing, phase lock loop 4. There's that zoom again. I don't know why. I did a little swaptronics. There's 3 of these. Let me show them to you on the schematic over here. I see one right here. It's a RC4558. Anyway, there's 3 of them in there, and since I don't have these, I don't believe, I just switched 2 of them around, and it made a difference. But what happened was R22 is the 250K right here, or the 250 megahertz adjustment. It was actually maxed out, so plus 18. So it was basically plus 18 going to this right here. I mean, full bore. So I have a feeling I probably got some more bad operational lamps, and I think those 4558s, I don't know if I have any of those, but I do have another board, so I got to go up in my attic to get it, and I got to do that here in just a few minutes with my wife, and now they're having a garage sale. So I'm going to get that other rig out, and I'm going to get that 172 module out, and I'm going to see what it does. Anyway, I'll talk to you later. Bye bye. Okay, it's been a few hours. It's been a couple of hours. Had to go do errands and eat and all this other stuff. But I went upstairs and got the Civilian 3001 and got the 172 module out of it. However, I didn't really think about it at the time. Put it in, it didn't lock, and when I pulled the cover off to adjust it, it did look the same. Anyway, the 170 module is actually an M22 in this rig, so it's not the same module at all. Okay, no problem. So going back over here to the module, there's 3 RC4558 op amps in there, and where is it? Yeah, there's one right there. But there's 3 of them. One up here, here, and here. Several of them in there. Anyway, I didn't have that. However, I got a fresh batch of 1458s. They seem to have the same ratings, and so I put them in there. And look at there. I have 0. I'm on 250 volts, and everything's cooking. So this section is done. Now I move down to set the output frequency. Let's keep going. Set the output frequency to 300 megahertz. Okay, 300 megahertz. They're not locked. M172 300 megahertz for 0. So as soon as I figure out where my adjusting tool went, it's getting late for me. I'm getting tired. I'm getting cranky. We'll come up here. Let me do something here. Come up here and adjust to 300. You know, I really don't know. That little pop you heard was my clip lead coming off, and it broke. Son of a, I won't say a bad word. I wish clip leads would pop off. That sound that they make just infuriates me. Anyway, where was I? I forgot. This thing's got troubles. There's something wrong. Yeah, there's something wrong. There's something wrong in these circuits. And I'm too damn tired to mess with it. However, it does lock perfect. I don't know. Maybe it's a bunch of bad resistors in there. I don't know. I'm too freaking tired to mess with it tonight. I'm going to shut her down and get back to it tomorrow if I have time. Alright, thank you for watching. Sorry I'm so grouchy. Well, it's the next day, guys, and I tell you honestly, you need to slow down, and that is something that's hard for me to do. You need to slow down and read this stuff more. You remember on the previous segments that I couldn't get my voltage levels every time I changed it from 250 to 300 to whatever, you know, that I couldn't get the output of the 172 module to be 0. I was like, what is that? I can't, and I couldn't understand why the levels just did not work. I mean, everything was screwy. So at work today, I sat down drinking a good fresh cup of coffee, and I started reading the manual again. So here we go. Let's reread this. Calibration of PLL4 involves 3 modules: the M172, the M9W5, and the M34-1. Test points are located on modules 172 and M34-1, while adjustment controls are located on modules M172 and M9W5. Now it says set the lever indicator switches to 250 megahertz, and all other front panel controls is in section 5.3.4. Connect a digital voltmeter, of course it's that one here, to M172 pin 1, which this is M172. This is, and that is pin 1. Be careful not to touch that clip. Anyway, let's see. Then it says then adjust M172 250 megahertz adjustment R22 for a 0 volt reading. Yeah, I'm gonna cough myself to death now. So just for fun, let's try it. You see? Does adjust. Remember, it would not adjust. It would not go to 0. It always stayed negative. I wound up changing all 3 op amps on that 172 card. Okay, you remember now. Now the next thing it says, very important, the voltmeter may now be disconnected. Didn't see that before. I was rushing myself too much. Very important clue about the next. Connect a frequency counter to the RF out. So here comes my RF out. Here comes my RF out. Down. All the way up and into my frequency counter. And then it's teeing off and coming down to my mod monitor. So here's a frequency counter, mod monitor. And of course the output, the audio output of the mod monitor It's going over to my scope. That's what you're looking at, the mod there, along with the next part. Anyway, connect freak counter to the RF out, which we've done, and connect the scope vertical input. So we have that too on channel 1 of the scope right there. The modulation meter is on input number 2. Anyhow, connect scope vertical input DC, set up for DC 1 volt per division to M34-1 pin 8. Here's M34. These here, it starts top 1, 2, 3, 4, 5, 6, 7, 8. So we are on times 1 on pin 8. There's looking at channel 2, and right now it's that flat line, and I'm going to let's calibrate it. I'm putting it exactly on the hang on, there we go. Alright, so it is, I've actually got it on 0.2 of a volt so I can get a little more precision. So again, we've got frequency counter set up. We've got the scope set up for DC to M34-1. Now we adjust module M9W-5 control A for 0 volt plus or minus 1 volt on the scope. So here's the M9W board module. Here, so. And believe it or not, I went through after I recorded the last segment and I actually tuned each one of these in turn and just set that line to 0, which unbeknownst to me, I was actually doing it right. So, look at that, we are reading exactly 250. That is good. Now, set the output frequency to 300 megahertz. And adjust M172 300 for 0 volts plus or minus 3 volts on the scope. See, I was trying to do that with that where I had the voltmeter on there. So let's go up to 3. Notice we're in lock. Notice it's just barely drifted. So we just come right over here. Make sure I got my little diddling stick in the right spot. This thing's been running all night too. Look at there. Exactly on. Boy, this is getting fun now. So, let's see. So I need to do 350 the same way. So we just set up 350 right here. It's locked. It locked fast. And that is almost on the money on the scope there. Okay, so I think the next step is 400. Yeah, 350, 400. So let's go up to 4. Off just a little bit. Come over here to 400. Alright. Man, I like this. This is working right. I knew something was wrong and I figured it was me. So I think the next one is 450. So let's do that. It's just tiny bit off. Like I say, I did this last night after I turned the camera off. And thinking I'm just going to adjust it this way. It seems to have the most effect. And little did I know that that I was doing it wrong the first time and doing it right without knowing it the second time. So anyway, look at there, 450 on the dot. So the next step is set the lever indicator switches to 500 megahertz. So we're going to set over here 500, still locked. Now my DC voltage just went away. There it is. I had to back it up. It's pretty close, but anyway, let's see what we do next. Let's see, set the lever indicator switches to 500 megahertz. Adjust 172, 500 megahertz adjust for a scope reading near 0. So going back over here to 500. And we're going to adjust it to near 0. That's pretty damn close. And the frequency counter is measuring right at 500. I like it so far. Alright, so increase the lever indicator switch setting to 520. Okay. 520. It's locked. You notice the DC voltage shifted high on there. See above the sine wave? So anyway, let's see, what next? Increase the lever indicator switch for a scope reading near 0. Increase the lever indicator switch to 520 and note scope indication. Okay, so we're at 1 volt per channel, so we're like 2.1 volts. Okay, so we're at 2.1 volts. Let's see. Then adjust 172, 500, adjust to give scope indications of 500 and 520 that are symmetrical about 0 volts. So, okay. So let's see what happens here. I'm going to go to 520, back and forth. I'm going to turn off second channel for the moment. I don't really know exactly what they mean. I mean, I don't know, we'll see. I think what that means is what I've done is I've set one for, I don't know, symmetrical to me means equal in both parts, positive and minus. So I've set 520 for plus 1 volt. I've set 500 for minus 1 volt. And it likes it. I'm up to 550, 560, 570, and it's still locked. So I'm going to call that part good. So far everything has worked according to how it should. So we wound up just changing those 3 op amps, and then B, learning to read the manual. So now we're going to set the lever. Hang on just a second, let me get you out of there. See if I can tear up my... So next thing we're doing is setting the lever indicator switches to 100 megahertz. Alright, so 100 megahertz. And we're showing 100 megahertz there. So we're adjusting M172 100 megahertz adjust R13 for 0 volts on the scope. And like I say, I've already done that. But let's bring this, see how close I've got it. I got it 50 millivolts per division, and it's just about dead nuts on. Yep, I think I've done, like I said, I'd done this last night. Didn't realize I was actually doing it right. Okay, so Repeat using the appropriate 172 for frequencies of 50 and 0. So let's go down to 50 megahertz. 50 is a little off. So 250, 100. Here we go. As this thing warmed up, I'm sure it drifted a little bit, but there, we are exactly 0, and there's exactly 50. So the next one, final one, I believe, is set the lever indicator for 001.0, so that's 1 megahertz, right? So we'll set this for 1, we'll set that for 0. Alright, so I set lever for 0 hertz adjustment. So here we go. That's showing 1.03018 something other. So I'm not sure what's going on there. Alright, well, done with that section there. I'm going to look, see why it's off on that one there, and probably misread something again. So anyway, I'll bring you back. Okay, between the last segment of this segment, had a little issue on this M172 card. The last adjustment was to set the 0 reference. In other words, we were doing the 500, 450, the 400, the 350, the 3, the 200 megahertz, then the 100, the 50. But all of those worked. Everything was zeroed on the scope over here, if you remember. However, 1 megahertz. 1 megahertz, like this is 2 megahertz right here. Okay, I'm going to set you up 500 megahertz, and why don't I have a lock? Oh, trying to figure out why I didn't have a lock. Anyway, I'm at 500 megahertz, 500 megahertz here, and the scope would have been where it's from. Anyway, when I got down to 1 megahertz, you're supposed to set to 0. Well, 1 megahertz doesn't work. You see, it's 1.043 megahertz. Don't know what the hell that is, but I moved on to other things. I'll get back to that. I'm going to continue on, keep that in the back of my mind. I don't remember that being the problem before, so I'm wondering if it was something that I did. I don't know. I played around with the reference, the high stability oscillator right here. It was right on. I hooked it directly to my frequency counter. It was right on 5 megahertz. I did a couple of other adjustments in here, verifying. The references are fine. So there's some other issue. I don't know what it is right now. So I'm moving on. So next thing I'm supposed to do, I've already done the phase lock loop 5 adjustment. I've got that done. Now I'm doing a meter board calibration, and first thing you do is you turn it off and you set the meter here to that little dot right there, which is already there, but we'll do it again. There you go. Meter set to that little dot. Turn it back on. So, momentary, turn the power off to the instrument. Mechanically zero the output meter with the front panel. Zero adjust. The meter needle should bisect the dot at the left end of the meter screen. Set the output vernier control fully counterclockwise. So, output, there's 0. And to the meter needle again bisects the dot at the left end of the meter. Set the output vernier completely clockwise and adjust meter board pot A for +3 dBm output meter reading. Completely clockwise. So I guess this means get the old noisy aircraft again. So I got to get my spectrum analyzer out. Alright. Going back to the adjustments here, the next thing it tells you to do is you turn your vernier all the way counterclockwise, which I've done, so that makes the needle come all the way down here. And we're supposed to adjust meter board pot something B. So that would be B. So that would be of course that doesn't match. So let me find the lid. Isn't this fun? Okay, we're just gonna do it. Anyway, this should be B. Should be B. That's a joke, son. Well, it must be it. Anyway, you adjust it back to the dot again. Alright, done that. So what next? Alright, so output vernier, adjust the dot to meter. Set the dot, see figure 5.6 locations of meter board pot. Set the output vernier control completely clockwise. Alright. Alright, so let's see. Then adjust meter board pot A for +3 dBm output meter reading. Okay. Let's see just how accurate that is. And some days you just can't get rid of a bomb. Let's see if the old, let's just set this for 200 megahertz. Doesn't tell me I'm supposed to. You got something. Okay, center frequency 2 megahertz. Frequency span 1 megahertz. So, oh, 200 megahertz, big dummy. But okay, so should be about. I don't know what to do next. Anyway, let's move on. I did what they said. Set the front panel controls as follows: frequency, vernier, calibrate. That's this guy. I want to set for 50 megahertz. Okay, that's that guy. Modulation mode CW. Alright. Modulation frequency, doesn't care. Minimum AM FM minimum. Output vernier full clockwise. That's what we have. Output step attenuator for plus 10 dBm. Alright, what next? Calibrate the power meter. I don't have a power meter right now. Set the power meter to plus 15, then connect the thermistor, blah blah blah. Adjust meter board pot F for plus 13 dBm power meter reading. Yeah, okay, so we'll just do it. So if that's minus 10, I guess, well, I don't know. Adjust meter board pot F for plus 13 dB. Oh, plus 13, big dummy. Need an attenuator, what I need. Attenuator. Well, I don't have an attenuator. We'll have to make it minus 20. I know why they want you on 10, because that's a minimum amount attenuation. So anyway, let's go here, audio. Plus 15. Well, minus 15. I went from plus 10 to minus 20. So that's 10 dB. So I'm at anyway, 15 dB. Well, anyway, let's adjust that. So where the hell is F? A, B, C, D, E, F. I don't know. These boards don't quite match. A, B, C, D, E, A, B, C, D, E, I have no idea.